iOS programmers, still with me. So in this video, we're continuing on from the previous video, looking to extend our basic iOS iBeacon app to now utilize Oracle Mobile Cloud Services Location-Based Services API to derive the iBeacon data from MCS itself. G'day, I'm Chris Muir from the Oracle Mobile Platform team. Now, in the previous video, we explored how to write a simple iOS application to detect an iBeacon based on hard-coded beacon identifiers for the UUID plus major and minor values. Now, in this video, we want to explore how MCS can make the app more interactive by removing those hard-coded values and relying on the MCS location-based services. Big advantage here is you don't have to keep on downloading new versions of the app to get the beacon identifiers. You can basically change them in the cloud. MCS allows you to modify them there, and your application can just download and reuse these. So let's work with a real use case moving forward to explain how this is going to work. Imagining we're opening a great new shop called Chris's Emporium of Knickknacks, and we'll be creating a great new mobile app to help customers buy as many knickknacks from our store as humanly possible. Now, because our esteemed CEO is technology savvy, he would love to set up a beacon just at the front of the store such that when a customer with our app installed on the phone approaches the beacon, we'll send the customer a personalized message offering them all the knickknacks they could possibly ever dream of to buy to entice them into our store. To support this scenario in MCS, we will create a place called Chris's Emporium, and we'll define an iBeacon with the following UUID, major and minor values. Now, returning to our sample iOS beacon application from the previous video, you'll note we've already hard-coded the UUID, major and minor values, so that's a problem that we want to remove. Second, another change we're also going to make is when we detect the actual beacon, the current message is hard-coded, and that too we'd like to retrieve from MCS. So with these 2 points in mind, let's make this application really interactive. Let's remove this hard coding by introducing the following MCS iOS SDK code. Now, we've covered in earlier videos how to introduce the MCS iOS SDK into our iOS applications, and we won't revisit this. So here in our code, we need to first get a handle on our OMC mobile backend and also authenticate the user. Now, for the purposes of demonstration, I'll keep this simple and I'll just authenticate anonymously. From there, we want to remotely query the MCS location-based services REST APIs. And as we saw in an earlier video, if we look to the MCS user interface, we can see in the tester pages that it supports a number of different endpoints, such as querying places, assets, and devices. However, thanks to the SDK, we don't need to make raw REST calls in our Xcode project. Rather, we can use the modules provided by the SDK to do the bulk of the work for us. So, here I'm instantiating a OMC location place query object, which will allow me to remotely query places from the REST endpoint places query. To use this method, we then need to define the query criteria. As I'm interested in only one place, Chris's Emporium, I query based on this name. Though I can also query by description, label, all places nearest to a lat-long coordinate, or in a geofence boundary as example. In querying by name, it's worth noting it is queried by wildcard, so I need to ensure I don't get any other Chris's Emporiums with a suffix returned. So I have to also limit the result to 1 and sort by name ascending in order to achieve this. Next, we call the async method execute with completion handler on the query object that will make the remote call to the REST API places query. Assuming all things go well, the result contains as a property an items array of OMC location places. Again, my application logic here, I happen to know there's only ever going to be one object we'll return, so I just fetch the index 0 of the array. Next, as our goal is to retrieve the device UUID, major and minor values for this associated place, I call the async function devices with completion handler on the OMC location place object. This will get an array of location devices if successful, and again, as I know we only have one device, I can safely extract the UUID, major and minor value, and create a new instance of the seal beacon region. With this in place, we are now dynamically deriving the UID major and minor beacon identifiers from MCS. Now remember, our second and final goal is to remove the hard-coded message from when the specific beacon is detected. Instead, retrieving a custom message from MCS, which we can dynamically change without needing to redeploy the app. To do this, firstly in MCS for the beacon, let's define a custom attribute, beacon message, with the value welcome to Chris's Emporium. Now this could be something much more dynamic, but it's suitable for our demonstration purposes here. Returning to our code, in the delegate location manager, did range beacons in region method, we can see our currently hard-coded alert message. So what we can do to remove this hard coding is very similar to the places query, except we'll use the MCS iOS SDK to do a devices query instead. What we do in our code is we again fetch the MCS mobile backend and authenticate the user. Now in reality, we never authenticate the user twice in the application, but I'm just being lazy here for demo purposes, so I'll just re-authenticate anonymously. Next, we create an OMC location device query object to in a moment query back a specific beacon. In the query object, we pass it the properties we want to search on. And as the did range beacons in region method is called when we detect a specific beacon and its UUID, major and minor values, we can use those values here as the query parameters. Having defined the query parameters, we call the async method execute with completion handler to call the remote MCS REST API to retrieve all the beacons associated with this UUID major and minor value combination, which we know will return just one. Then in the result, we can then extract our custom message property and display this in the alert. And returning to our demo here, where I'm just projecting again my iPhone onto the screen here so you can see what's happening. As I bring the dot close to the red beacon dot close to the device, you can see the application now displaying the custom message. As you can see, working with the MCS location data is a doddle when you use the MCS iOS SDK. And it really isn't hard at all to remove the hard coding from your app to make your app much more flexible for your business needs.